Okay, so where we finished yesterday is we were dealing with electric fields and we were showing those electric fields. So I'm going to start with a constant electric field tonight. And we're going to assume that we can make a nice uniform electric field. And we talked about how we could make that. In fact, the easiest way to do it is to take a plate and put a positive charge on one side and a plate with a negative charge on the other side. And then we can apply, we'll talk about this and we'll get there and we'll apply a voltage to that. And that will allow us to create our electric field. So I'm going to give this electric field, we're going to get a magnitude of it. That's going to be 500 Newton coulombs. And we want to drop an electron in here. So we're going to drop our electron. And we want to know what the acceleration of that electron is. Okay, now if we drop this electron, first thing that we know is that we go from positive to negative. So my electron is really going to want to go in this direction, right? Because it's going to want to move away and it's going to be attracted to the positive side. So if we want to do that, first of all, we need to know what our charge is. Our charge on our electron is a negative 1.602 times 10 to the minus 19 coulombs. And the mass of our electron is going to equal 9.11 times 10 to the minus 31 kilograms. And we knew, and where we saw yesterday is that the force is going to equal mass times my acceleration, which is also equal to the electric field times the charge. So we can actually calculate our acceleration and our charge. So we've got that's going from that perspective. And so we're going to get our acceleration is equal to EQ divided by our mass. And if we plug in our negative, if we've got our negative electron here, I've got my 500 Newton coulombs times my negative 1.602 times 10 to the minus 19 coulombs. And I've got my mass, which is 1.11 times 10 to the minus 31 kilograms. We're going to get a negative, which is telling me the acceleration is moving it away, which is great. And if I plug in my numbers, I get 87.9 times 10 to the 12th meters per second squared, which is something that we saw before. If I want to find the speed at a time afterwards, so if I've got a speed at 1 picosecond, I'm going to get velocity final is equal to velocity initial plus my acceleration times time. And if I just dropped this in, my initial velocity is going to be 0, so that would do that. And I'm going to have a negative 8.79 times 10 to the 12th. And I've got a picosecond, which is 1 times 10 to minus 6 seconds. And that's going to give us our 87.9 times 10 to the 6. It's going to be a positive 6. And that's going to be in meters per second. And we're going in that direction. Okay, so if we've got those things that are there, that's going to give us a good handle on how we can look at our electric field.